good. Good. Let me again for the third time because I really want the YouTube stream. It's like our recording. Okay, again. So what I've done, very small change. So on week 3, on week 2, on day 3, on Wednesday, when I said we'd have the master class for programming, we'll still have it, but it will be only C sharp, which is like even more true now because that's what a C sharp masterclass would be, or coding masterclass. And this thing, best practices and design patterns, would be like 80% of the whole time of the whole duration, right? And previously it was like C sharp and C sharp meets Unity in the same day tree, but it's too much. They are too big subjects in themselves. So I've pushed this C sharp meets Unity on day 4, and whatever was on day 4, I pushed it here in microservices, and whatever was on day 5, I pushed it on week 3, day 1, and it was these things: workflow and building for various platforms. And these things are won't take too much. Yeah, it's very it's doable. Like 2 hours, I think we'll finish it, and that's all. Like that's the only change. Um, so for those of you who, hopefully like every one of you, but for those of you who've been here since the beginning, uh, like you saw this curriculum, and I just wanted to show this small correction here. Good, let's do it. So we're live. We have, okay, we are recording. So yeah, day 2. Welcome again. So we'll do some physics part 2. So we did physics part 1, and here we'll do physics part 2. Still not very in depth. Like if you're interested in any of these, or in any things that you think there, I mean, I won't present everything, but if you want some more advanced use cases, you just have to look it up yourself. But yeah, basically we'll do some physics now. So anything doing with loads of physics, right? How to apply physics. And the cool thing about this is we are, oh, none of this do we, none of this is programmed. This movement, like we don't program this movement, it happens automatically. We are just defining the masses, the shapes, the physical material of objects, like how bouncy they are, how much friction there is between them and other objects, and so on. Yeah. And as you remember, we've used rigid body already because it's one of the most low effort, high impact thing to show about Unity, at least for me. And that's what I really liked when I first opened Unity, and I just created a sphere, and I've compressed it and turned it into like a square, rounded square, and then I threw it from from above, and I watched it come to the ground, and just I really liked how it collided and everything. And I didn't need to do anything. I just I dropped it. Yeah. And we've already talked about mass drag. So I mean, mass is what mass is. Basically, it's a very close approximation of mass. So if you have like a 10 kilogram object, it will push objects that are lighter than it. So like it's exactly how you'd expect, right? So if 10 kilogram sphere and 1 kilogram sphere, of regardless the size, they will, if they will collide, like the 10 kilogram sphere would just push the 1 kilogram sphere, and so on. And like you can have a 1,000 kilogram small sphere and 1 kilogram very big sphere, and it will still, this one with the with the bigger mass, yeah, a bigger mass, would just push the one, right? Um, Drag, I haven't used it that much, honestly, but it has something to do with I think if you increase this too much, or I mean, if the more you increase this, the harder it is to push an object. And I think it has something to do like simulating how much air there is, because basically the density of air, I think. So yeah, I have so much experience in Unity, but I haven't used this too much. It's one of those things that you just leave it as it is because you don't need it. You never needed it. But yeah, this is a way of, I think, of simulating the density of the air, but only for this object. So it's kind of selective, right? So you can do it for all of the objects. I don't know how you do that, maybe in settings somewhere. Or you go into each object and tell it, okay, for you, the air has whatever density, 50 or something like that. And I think it's, I'm not an expert in physics, but definitely an object moves differently in different mediums, right? Like an object moves in certain way in water than in the air, right? Even though it has the same mass. And then we have angular drag, and this is exactly the same thing as this, but it refers to angular movement. So whatever that this means, this is for rotation. So this is for movement. So when an object is pushed, what its drag is, and this is for when an object is rotated. Yeah, automatic center of mass. This is, I think, a new one, or maybe just like it has make a maximum of 5 years. This thing, if I remember correctly. So I guess it makes sense to put it here. But if you don't click it, I think I don't know what happens if you don't. So we are on day 2. Yeah, let's just create one quick. Yeah, if there's no center of mass, by the way, you can do this. You can go here and you can just drag the component and move it into this other object. Wow. Oh, interesting. I thought it works. I'm pretty sure this works on Windows. Well, copy component, right click, paste component as new. Okay, so automatic center of mass. Let's put it back to perspective. And center of mass, I don't think I can see it. Yeah, you cannot see it. You're basically trying to guess it. Most of the time you'd want to leave this like this, right? So it will try to, like if you have a very weird shape, it will try to approximate where the mass is, right? Where the center of mass is. But yeah, you can like change it. So if you do it like this, so current center of mass is 0.5, 0.5, 0.5, or no, it's actually 0, 0, 0, because this is the position of it. This is the pivot, right? And this is like in local space of the cube. So if I create a sphere and let's make it smaller. So the sphere has the position 0, 0, 0, and because it's parented to the cube, it's exactly in its center because that's where the pivot of the cube is, right? And if I put it like, and if I move the cube like here, you see the cube has this position, my x minus 5, y 0 point whatever, z 1 point whatever. But the sphere is still 0, 0, 0 because it's relative to its parent, right? And yeah, like the cube has no parent, so it's like it's a root object or a scene object. So it's here is the absolute position of that object. Good. And if I put like 0.5, the sphere will be exactly on the edge of the, like the sphere's position will be exactly there. Right. And let's see, where was I going with this? Oh, with center of mass. Yeah. So center of mass, if you want it to be in a different place, you would basically do, let's say, 0.5, and y would be 0.5, and z would be 0.5. And you can, yeah, this is a trick. Like if you want to see where the center of mass would be, and I'm sure they will add this later. I'm sure they will add it. You will basically add a child to this cube and just set its position to the same position as the center of mass. And here will be the center of mass of this cube. And I think the way it works is, imagine as if your cube is made of plastic or something like that. And in this part, so in this corner here, you have it like, you have this corner made of metal or something like that, right? And it will behave differently. For example, if you hit it from here, than if you hit it from here, right? So that's why the center of mass works like that. And yeah, that's why that property exists. So you can use it that way. Automatic tensor, I don't know what it is. So I don't know what it is, but I'm pretty sure a physics expert could understand that. Use gravity is self-explanatory. If you uncheck it, then the cube will not fall. Yeah, if you check it, bam, it falls into the abyss infinitely because there's no ground. Okay. Is kinematic, we talked about this. So if is kinematic is turned on, it's toggled, then it overrides this use gravity, and basically it doesn't matter if you have it on or off, because this kinematic overrides it, and it means that it waits for you to move the object through code or through other, like, I don't know, you press a button and you do something like there are other, like, programmatically, like you move it through code, or some very, like, if you really really want to do it this way. So you have a button, here's the button, and in on click we have the cube here, and we do transform dot. Can we do this? I don't think we can do this. Yeah, we cannot do this. Yeah, you can't really do it through here. You will do it through code. I thought we could access the transform component and like set the position. Good. Let's go back. Yeah. So again, is kinematic. It doesn't So if an object collides on this object, it's as if this object has infinite mass, but it cannot be moved. So it's static. It waits for you to move it. So basically Unity will use it for every physics calculation. So for friction with other objects, or if other objects collide with it, and so on and so forth. But physics will not move the object, this object. It will wait for you to move it, and nor rotate it, right? You can also maybe, like, if you want like a mnemonic, you can think of it like it's cinematic in a way. That's how it's hard coded in my brain. So it's like cinematic. So it's like somebody has to move it. It's like scripted. It's not real physics in a way. Interpolate. This is a cool thing to talk about if you want. Or actually this one. Interpolate, I think it has to do with basically more accurate collisions. So yeah, I'll have to uh, just read about it, but it's not that important. Like if you want more realism, I think you would have to choose interpolate. But this thing is very interesting. So, and I think we've talked about it, but basically because you have constant frame rate, you have like 60 frames per second, let's say, and you can that means that physics are calculated 60 frames per second, so 60 times per second. But if your object moves so fast that on one frame is on this side of the cube and on the next frame is on this side of the cube, no collision would have happened. So it's as if it teleported, because that's what really happens. So the object teleports like this each frame. It doesn't go like this because it has such a high speed that it shows like this, right? But if you, and basically there will be no collision. So objects could go through walls. But but you actually have to do it on the sphere. Let's say if the sphere is the one that moves, right? Let's add a rigid body here as well. So this is what discrete collision works. Yeah, and it even says it here. So that can help solving fast-moving object issues. But if you want to do it continuous, it's one step closer to detecting objects that are going through that have such a high speed that can go through walls or get stuck in walls and so on. And I don't really remember all of this. I only knew about discrete and continuous, but I'm pretty sure that the more you go to the bottom, like the more accurate it becomes. So I think this one is like the highest level of physics, and it takes the most amount of CPU. So like even if you have a low frame rate, like this, your object would go like this, like it would basically go through it. This thing would basically catch it and just push it back like this way, right? And it will also detect a collision with this, like, this is another message. Unity calls them messages, so it's like a special function name. So you can have any function name you want, right? But if it's a special function name inside the mono behavior, basically it's called for you, and you can react with it here. You can do whatever you want. And this collision is like the collision object. And we'll talk about objects tomorrow. But an object is, like in programming, not in Unity, but in programming, like an object is a thing that has properties and that has functionalities. And the collision is a noun, right? It's a concept. So a collision, what does describe a collision? It describes, let's see, object or whatever. It needs at least the the object with whom this object collided, right? And you have its collider component, but this is the game object, right? The game object whose collider you are colliding with. And you can see like what's its name, what components it has, and so on and so forth. And yeah, this is how you can respond to it. Let's okay. Yeah, and this is the rigid body. And the collider defines the shape of the collider, and we talked about this in the previous sessions. Um, and of course, you cannot have a rigid body without a collider. I mean, you can do it like this, I think, but then the rigid body has no. Will it still work? Oh yeah. So you can have a rigid body without a collider. It's just that it would be impossible to collide it with anything. Oh, actually, you can do this thing. So you can do freeze position. Y. And then you don't, I mean, maybe you want it like, I don't know, I cannot add any force to it now, or can I? Hmm. Interesting. Oh, so the sphere, yeah, basically doesn't collide with anything. But if you apply some force through code to this ball, it will just go like this, right? Bam, bam, bam. It will go like this, but it won't collide with anything. So if it doesn't have a collider, or if its collider is disabled, right? And it won't go. It won't be affected by gravity because we froze its position. Oh, but we could also just disable gravity, and it's the same thing. Yeah, I don't know when would you use such thing, but you'd usually in the collider. And yeah, you have the most used ones are box colliders, which are these colliders, and they are added by default on your cubes. You have to press this thing if you want to give it another shape, right? And you have sphere collider, the next most used ones. Then you have like capsule collider, and they are automatically added to your, like if you're creating a cylinder. Is there a cylinder collider? No, there's no cylinder collider, I think. Yeah, there's no cylinder collider. It's just, you see, it's a capsule. So if you edit the collider, this is it. Like this would be like the actual collider. So basically, if you throw a ball, it would collide with like this. Like it would go inside the cylinder for a bit, right? That's how it works. Um, yeah. But of course, you can have a mesh collider. And if you have a mesh collider, you have to provide the mesh. And no, actually, it uses the mesh collider, yeah, on itself. And this is the collider. I don't think you can see it. Convex. Yeah, I haven't used this too much. And now, if you throw a ball on it, like it will ricochet exactly from this thing. Like you cannot put this sphere inside it, right? So it's like exactly the same as its visual shape. But of course takes more computing time, and that's why by default cylinders have capsule collider because it's easier to do calculations on simpler shapes like a sphere collider. So yeah, this is a mesh collider. Basically, it uses the mesh from mesh renderer here. But of course, you can remove the mesh renderer and you see you are left with the mesh collider. And yeah, I mean, you can add any mesh you want. Like you can add the sphere collider, right? And if you add a sphere collider, see the sphere here? That's like the sphere. Because is the mesh is an asset that has most of the time it has the extension FBX or OBJ, and they represent 3D models that are exported from your 3D editing application. And so, most of the time, like you're either downloading them from Asset Store or from a 3D assets store. I don't remember. It was there was a very popular one. I don't remember, but there are lots of them. Or I mean, your 3D modeler gives it to you if you are working in a team and so on. But yeah, cylinder. So yeah, this is how you can have also a mesh collider. And of course, like if you have a very complex dragon or something, you can use a mesh collider, but it will consume some resources, a lot of resources. And the way you would usually do it, like imagine this is a very complex shape, you just create colliders like this. So you have a head and you have a sphere collider for the head, and then you do arm 1, and you do a capsule collider. Capsule collider for arm. And I don't know, like this, I think. Yeah, something like this. And you do it like this. I'm using the shortcuts, right? I'm using E for rotation and so on. W for moving it and so on. Control C, Control V. Then I put it here. I rotate it like this with Alt, I think. Yeah, so you can rotate it in increments. And yeah, you know, you got the idea, right? These are like the arms, right? So this is your arm, head, and so on. And of course, we won't go into animation, but yeah, that's how it works. So imagine you have like a very complex shape here instead of the cylinder, right? So you remove the mesh collider because it would take a lot of... just imagine there's a dragon or something, right? And if you do it like this, when this object collide, like if an object collides with this arm, Unity tries to send that on collision enter and also just collide. So it tries to send that on collision enter to the first game object which has a model behavior attached to it. For example, this thing, if it doesn't have anyone now. Let's say we have it here, like we've created the on collision enter, right? It will send that on collision enter to this object, even though it collided with this object, with the arm, right? Because the arm doesn't have any script that defines that on collision enter. And obviously the ball would also just ricochet a bit, and also the whole object would move a bit, right? Depending on the where are you? Well, it needs the rigid body. Depending on the rigid body's mass, right? If it has a very high mass, it will just move like small thing like this. Yeah, we can go, I think, through this. So I can, let's say, don't use gravity. Let's actually test my hypothesis because I didn't do this for a very long time, and let's just not use gravity. I really want to see it in action. EC component, there's no collider attached to cylinder object, but the script is trying to access it. Where are you, man? What are you trying to access? Oh, because we've added a... Let's remove this thing. Okay, let's see. So we move a sphere like this. Oh, yeah, it works. So you see it, and of course the sphere has this some angular velocity now. We should do it like freeze rotation for simplicity. Let's reset its rotation so we can drag it. So you see it collided with this thing, and if we do it like this, it also, you see, both objects are, you see? So it works exactly as expected. And you see also the, yeah, I see the object, both objects have some velocity now because of the collision. Yeah, so that's how you create really complex shapes, but still allow them to collide beautifully. Because for collisions, like, you don't need each finger, each nail to be completely specified and everything, right? You only want it to appear realistic. So that's how you do collisions with complex objects. And of course, with this guy here, it only has a capsule collider, right? This is its real shape, right? So it's all good. It's like getting like 99% of the result with 1% of effort or something like that. Yeah, and there's I don't know, terrain collider and all of these things like 2D colliders, which I don't know, I just haven't used them too much. It's really good to go into them, but I don't know. Let's say if I'll go very briefly to them, like capsule collider and the rigid body, and the reason we have the 2D version of physics is so that we can separate them, because 2D is less intensive than 3D, so it takes less resources to to compute. So if you want to squeeze every bit of performance for your game, you'd actually use a rigid body 2D and a collider 2D. And you can have like a polygon collider if you really want to go the manual way. Let's go capsule collider 2D. So this is a capsule collider 3D. And I think we can do it like this. Yeah, with Alt or Option, you can do it like this. Right, and this is your, and you'd have to create like a 2D object, sprite square. And this is basically just an object with a sprite renderer on it, right? And the sprite is a square, which is from this 2D sprites package that we've imported from, it's a built-in thing in Unity, but you have to import it manually. And yeah, and that's it. Like it's a sprite renderer with a square image on it, and that's it. And this is the square, and we have to add it a collider, of course, box collider. And yeah, let's see our player, which is a 2D player 2D, and it should work. So the player has a rigid body. Okay, simulated, I don't know what this means, is the body to be simulated. If not, it is effectively hidden from the simulation. Oh, okay, so it's like enabling or disabling physics for the subject. Yeah, it's probably different. I don't know why, but you could have probably just had the checkbox here. It's the same thing. So they might have their reasons. Yeah, so don't worry, yeah, don't worry. So this is Oh, okay. Yeah, because this one is because there's no depth concept of depth in 2D because you press this 2D thing and it's like this, right? So this is your player. You see, goes like this. If I move the square, the player just falls to it because the 2D simulation and the 3D simulation, they are independent from one another. That's why you have different uh, things there. See, so basically this is how it works. Yeah, I don't know if there's anything else to show here. It's just the same things as before and probably some other things like information. I don't know, Yeah, we won't go into these things. And of course, you can freeze position on X and Y because the Z position is frozen by default. It's actually non-existent. And also rotation, you can freeze Z rotation, which Z rotation is like this. You can rotate it only like this, you see? Using physics, at least, you can rotate it like this. But of course, in code, you can also rotate it like this, and nobody, like the physics would not even know about it, I think. Let's see. Yeah, actually, physics knows about it, I think. Like if you make it smaller. Yeah, they work pretty well, but I mean, this is very like a corner case. Yeah. So this is your 2D physics. So if you're making a 2D game, 2D only, and you're never thinking like having like depth in your game in the sense that you don't have physics depth. Of course, you can have um, like cubes and everything, and like for example, you can have a cube, and you can add a 2D collider, box collider to this thing, right? And you can have it like this. So I mean, you have it 2D, but maybe you don't want it like orthographic. You want it maybe like this, right? And if you move this guy, it will also work, right? Because this collider now is 2D collider. And of course, you can remove the mesh, so it doesn't matter. The mesh is only for visuals. Even the mesh filter and like the physics only cares about objects with the collider component on them, right? I don't know where you are, but yeah, that's basically 2D collisions for you. And yeah, let's do this thing as well, but yeah, let's do these things as well. So let's create a player 2D polygon collider. So the way it works is, never used it before, but this is how it works. Basically, it's kind of a mesh collider, but I think you also have edge collider, custom collider, composite collider. I think it's the composite collider that I was talking about. Yeah, you see, you can really like you can really do the this way. Um, yeah, it's a very it takes a lot of time. I know about custom collider material. I know how this works, so let's just leave it. Um, there was another thing like edge collider. I don't know how this thing works. Yeah, I thought I can just manually edit it. Oh, I think it's just like just a line, right? So you have like a line that's colliding. Okay, that's how I think it works. That's how I think it works. So this guy will basically fall half. Well, it falls in the first guy. Yeah, that's how it works. Basically, the line is here, line color. Yeah, anyway. You get the idea? Yes, there are many components and many things to explore in physics, and it's better if you explore them yourself. For example, there's also wind. So you can have, for example, a fan, and you can have some things on the fan, I don't know, some strips of something, and you can see those strips doing like this. Like you see class like a regular standard fan in many scenes. It's like that, and you can have some particles that respond to physics. um I don't know, maybe bubbles, those devices that have some soap water with some things, and you can blow through them, and you see balloons, soap balloons, right? That's how it's called. And you can blow them in the fan, and the fan would basically push them on the side. And if you want that thing, you can do that as well. um you can have chains like we saw in our first here. You can have a chain like this. We won't go into it now, but yeah, it's a cool thing to do. Like in 2016 or something like that, when I tried to create a more complex, basically I worked on some molecules, simulating molecules that had like spheres would be the atoms, and the bonds would be like a chain, but they had to have circular shape. Like sometimes it would go like into itself. It was like a closed graph, and at that moment, like I couldn't do it in Unity, so I had to program it by by hand, and it took me some time. Um, so you could actually take an atom and move it, and basically to move um the whole atom, and it was like it was for some protein folding project, but like the project was just stopped at some point. But it was really cool to learn that. Sound. So let's do some sound as well. So about physics, like I said, just look if whatever you want, like terrain, wheels, cars. If you want to create a car, let's actually do that. Like it's of course there are packages, and I probably would need to um we need to add some controller to that. Um, yeah, I have like you cannot add a component because you already have a collider. Yeah, in order to create a car, it really makes sense to import an existing template, and the Unity has something that's called standard assets, and you import that package, and you have lots of standard already made things, and you also have a car there. And depending on what you want to do, you can just either use the car as it is and tweak its parameters. There are lots of parameters, like how heavy the car is, whether the traction is in the front or in the back, and so on and so forth. Yeah, sphere. But the way it works, it has this. I mean, there are some. There are the wheels, and of course, it's some wheels. I don't know, something like that. And there's like a wheel collider, and the wheel collider works a bit differently. So it's kind of a cylinder, but because um, in order to have a higher fidelity to physics and higher more realism, you just use a wheel collider, and you have like a mass, suspension distance, and all of these things, right? Yeah, actually, if you want to create a car, I think you just create like 4 of these things. Or let's be cooler, like let's create like a motorcycle, right? And you have 2 of these things, and you have a cube. Oops, I was using the shortcuts. right? You have like a something like this, right? This is like a motorcycle, and let's do it. So you have like a motorcycle, but let's, well, I mean, it doesn't matter where the center of mass is. So this is your motorcycle, and I think if you can add a rigid body to it, right? You add a rigid body, and you have these wheels. Yeah, well, actually, 1.5. And the rotation, 90. Or actually, because we want the Z is forward. Wait, why does the... Oh, the collider stays like that. Where are you? Center, rotation. Why isn't the... Oh, I think... I don't know if this is the case, but... Oh, I think they really thought about this, right? So they are right. So our motorbike is actually the forward direction of our motorbike is that way. So we basically have to uh yeah, let's reset this thing back to a cube. Do it like this, then like this, then like this. All right. And yeah, they really thought about this, man. That's cool. So 0.5, not Z. Oh, yeah, actually the local Z. So this is our wheel, and I think, yeah, this is the suspension distance. You can play with this. And let's copy and paste it. Yeah, and like you can create suspension and all of those things, right? Good. Now we can... I mean, I still want the motorbike to be at the center of it all. So this is just an empty object, right? And I'm selecting all of them now and parenting it here. So now the center would be here. It's more intuitive. Okay, let's see if it works. I'm really curious because that package, I mean that package in standard assets, probably it's called like racing or whatever. It has some helper scripts, like some scripts created by them, where you have an actual... So instead of going here, you have an actual like car handler or whatever, and you have lots of parameters there, right? And yeah, I really created also on a small simulator for some cars that were crashing into one another. It was pretty cool at some point. Let's see, will it work out of the box? Oh, something really bad happened. Rigid body, cube. Yeah, I really don't know what happened, so I don't know if I will have the time to explore it. I don't know, let's try to just move it manually. Yeah, something really bad happened. Yeah, I know, suspension, force up. suspension spring, mass. I don't know, maybe try a smaller mass. 2 and 2. Yeah, well, I don't have time for this. This wasn't planned, but there's a standard assets in Unity which have a very similar setup like this. And yeah, basically you can try that one and look into it. Let's just try something I want to test. I want to test a hypothesis here. Okay, this one works. So yeah, it tries, like, I really wanted it to work because I know it's easier. I know it's very easy. I just don't know what's missing, right? Yeah. Or oh, I know. I think what happens. Let's freeze the rotation. Let's freeze the rotation. So yeah, and also the Z position, just for simplicity. Oh, okay, our motorbike is just flying. Anyway, you can look into it. I won't try to make it work now. Good. Sound, as I said, let's do some sound. And for sound, it's pretty simple. We have an audio source and audio listener. So the source creates the sound, and the listener hears the sound. And in our scene, we have the camera by default has an audio listener. And Unity just doesn't allow you, like, you might want to create a lot of cameras, and of course you might you'll create that. For example, maybe you have a racing game and you want to stream the camera towards the texture on your mirrors, the car's mirrors, right? And by default, cameras are created with a listener, and Unity will complain that you have two listeners in the scene and it doesn't know what to do because you only have one speaker in your headphone or whatever you have, or two speakers or whatever, but it doesn't know, like, where's the listener in the scene because you have two of them. And you need only one, right? And you're basically would just remove it, right? Remove component, and that's the way it works. So here's our camera, and basically the way it works, it's like you're seeing it like this, right? And if a sound happens to the right, you'll hear it in your right ear, and if a sound is on the left, you'll hear it on the left ear. Pretty easy. And you just have an audio source that you know, if you move it from one place to another, I don't know, we can even try it now. We have an audio clip with droplets. It's a 3D sound settings, yeah. You can have this Doppler level, so if you're like a sound engineer or whatever, you have a lot of things to tweak here, because sound is pretty easy in terms of coding it, where you only work with sound. There's nothing visual, there's no collision, there's no, like, uncertainty or bugs, or I mean, there will surely be some bugs at some point, but most of the things you can do them visually here, right? Volume, pitch, stereo pan, like if you want it to be slightly biased towards the right ear for some reason, I don't know. Oh, there's also this spatial blend, like 2D to 3D, and I don't remember the way it works. How much this audio source is treated as a 3D source? Um, I think you still hear it in your left and right ear if it's here, but in 3D, I think, but I'm not sure. Hmm. I think like if you have a more than left and right channels, you might also hear it in the front and the back, but I'm not sure. Um, yeah, and you have like Doppler effect, you know, like an ambulance, if it passes near you and then it goes like it goes in the other direction, you hear it slower and slower, right? That's what Doppler effect means. Yeah, and let's just try it. Yeah, you're hopefully hearing it. Oh, it's not looping. Yeah, I think I have to. I think this is what. Yeah, yeah. Okay. 2D means I don't know why they call it 2D and not 1D, but I'm pretty sure there's a reason for it. So you see, like now it you can hear it in the left ear, right? And now you hear it in the left right ear, and that because here's your camera and here's your listener, right? And I mean, if you move the camera, it's the same thing, right? Because the sound is somewhere here. You might even see its icon here. Now it's in the front, and of course you can rotate the camera. Yeah, that's the way it works. Let's stop it. Yeah, you already have a listener and it's your camera, and you might not even think about it at some point. Like you just put sounds where you want them to happen, and you just automatically see like, hey, that's nice. Like I hear a sound, and but the only thing is that you have to um, slide that to the slide this thing here towards the 3D. Not this thing. Where are you? Towards this thing, if, towards the 3D zone, if you want it to be 3D. But you know, like if you want an sound to always at least be heard a bit, you will add it here, right? So the sound will always be heard, but it will also have like a 3D effect. It depends on how much you want of each, right? If you drag it to the maximum, I think like if you move too far away from the sound, then you will not hear it at all, right? And that's how it works. And it has some things here like volume. I think volume doesn't have anything to do with it. It's this spread, I think. No, not spread. Oh, this is the minimum distance, and this is the maximum distance. Okay. Oh, okay. And the maximum distance, I think you can see it like it's very large. You see it like this. This is like the maximum distance that you hear this sound in, right? At which and this is like the minimum distance. Like if you go really inside it, you will not hear it. But I don't know. Should have been maybe like this, like 0.1 by default. Seems to me like 0.1 would have been a better setting, because like if you're going really inside it, you're not hearing it at all. Anyway. Yeah, you can add as many audio sources as you want. So if you're dropping an object or shooting a bullet, like you add an audio source on the pistol or whatever gun you have, and yeah, it will work. On a car, you put it on as a child of the car object, and you can put it like in the front in the engine, one of them, so you can hear the engine, and one at the exhaust, right? And you have then some the exhaust specific sounds, like in a very super sport car if you want it. Yeah, so you can do lots of things like that. Yep. And let's do an example. Yeah, let's do that example, but I already have it. So let's create a plane, create a cube, and I already have it like that. Let's card changes. Let's see, day 2 sound. Day 2 sound. Basically we create a plane, where this plane, right? Right click, 3D object, 3D object plane. This thing here, bam, it's a plane, right? And we have it already. And we create a cube. This is the cube. Oh, this is actually the cube. And like you see, I've created like this. So I've created a cube and I created 2 smaller cubes and they're like eyes. You can see the eyes. Let's switch it just back to this basic game view. You see, this is an eye and another eye. And add a rigid body to the cube, a collider, and an audio source. And we added an audio source on this cube. So I added a rigid body and added an audio source, right? So it's a component audio source, right? That's how you add it. Assign a sound file to it, and we've assigned this hit ouch.
Ow! Ow!
So there are 2 sounds. So first is a hit, and then it's a ouch sound. Put it in the air, then create and add this script to it, and the non-collision enter plate. And we have to look at this scene. So here, you see, we have this ouch sound and this script which we've already created. And of course, again, you can create it like either here or here, like you create C# script and you call it whatever, right? Like that one. And then you double click it and yeah, we won't be using these things, so you can just delete them for simplicity. And you write this thing. I've already like created it here, and so it doesn't show. Well, yeah. On collision enter. That's the message. That's how it's called. A special message that Unity calls for you if you have a function with this exact name and this signature. Actually, signature means what it returns, its name, and what parameters it gives you. So void means none, and the collision is the one specific for this one. And you don't even need the collision, and I think you can even do it like this if you don't use it. And you basically do get component of this object. So the object on which this component is attached, the cube, will get the rigid body, the audio source, and we press play. So it's a function that's called the play, basically. So that's how you play a sound through code. And there's this thing, play on awake, which is on by default, and we have to uncheck it basically because it will automatically play, right? Because for example, when you want to create a bullet, you have a prefab for a bullet with an audio source and everything, And that's, I think, the rationale behind it. Like when you create the bullet, it would automatically also play the sound for it if you want it, if you want to add a sound like that. So that's why it has play on awake. And awake is this thing. We'll talk about it later, but this is the awake. Basically, comes before start. So usually you start with start and update. That's what Unity gives you by default, so you don't have to write them. But awake happens even before start. And there's more nuances to that we'll talk about later. But all in all, that's why it's called play on awake. It prevent playing on awake if you uncheck it. And guess what it does? So we have a rigid body and a collider and a plane, which also has like a mesh collider, right? And a cube. And when the cube falls on the ground, collision starts, and thus we enter here, and we get the audio source of this object, and we press play. And the play has this sound here. So let's see.
Ow!
Yeah, that's pretty funny. Again.
Ow!
Yeah, let's do it again. But I mean, when you first play the game, there's some things happening. I don't know, some loading stuff. Let's like do y being 5.
Ow! Ow! Ow!
Yeah, that's pretty cool. Very simple example, so you can understand the concept. Yeah, for sounds like this, cut the silence at the start. So I already done that, and you do it through Audacity. So you have Audacity is a very cool app. It's free, and you can like record yourself. You can do lots of things. Basically, you have to open it in Explorer or Finder, and just okay, drag it here, and I already did this. So
Ow!
you see, this is like
Ow!
the first the hit and then the ouch sound. But it was previously like it was something like this, right? And when you basically have when you play the sound, it doesn't. No. Anyway, I'm not an expert, but initially we had like this thing here, and when you play the sound, it doesn't hit immediately, right? And you would see first the hit and then the play. And like instead of going in code and like scheduling for the sound to play after 0.5 seconds or something, it's easier to just edit the asset itself, right? So you tell your sound artist or whatever, please make the sound so it starts immediately, right? And you just select it and you just press delete, and that's how it starts right now. Well, I have to click like this, right?
Ow!
Right? And this is a very important thing. I mean, it's a simple thing, but important thing for hits and stuff like this. Yeah. Let's use a reverb zone now. So for example, if you enter a cave, so you're outside, you're in an RPG game, you play, you whatever, and then you enter a cave, and suddenly your steps start to have a reverb and so on and so forth. And this thing is one of those small things that can give you a lot of value with relatively low effort. And I already have it here. I think, yeah, I have it here. So I have only this one scene, which has an audio source, right? I won't show you again how to create an audio source, right? Or I don't know, did I show you? So you basically just create, I think effects or create, or audio. audio source. Bam, that's your audio source, right? And then reverb, you see it here, audio reverb zone. You can do audio reverb zone. But I mean, you can also do it like create empty and just add an reverb here. Audio reverb zone and filter. I don't know what it means. I don't know how it does. It's complicated. I mean, it's not complicated. It's complicated when you don't know something. It's infinitely complicated, right? But maybe it will take like 5 minutes to learn it. And now you have an audio reverb zone as well, right? So it's just an audio reverb zone is just an empty game object with an audio reverb zone component on it, and that's like everything works. So just think of in terms of first principles. Don't get scared of things, or don't think that they're more complicated than they are. Good. So I've created an audio source. And I mean, I've created an audio source in the reverb zone. And let's see what settings did I create here. The minimum distance and maximum distance. This is like, so this is like the sphere, like it's exactly like the audio source in a way. So I think like inside this minimum distance, you would hear the maximum reverb. And outside of this, you'd hear a smaller and smaller reverb. And outside of it, you don't hear any reverb at all. I think that's how it works. We'll see now. Things sound different in different rooms. So example, we create an audio source, drag the droplets.mp3. So this is audio source, we've created it. We drag the droplets, which is this thing, which you are already familiar with. Okay. And create an empty object, edit the audio reverb zone. Yeah, that's how I've done it. I didn't even know that that's an you can create it directly, but okay. Then play it, hear it, then move the camera out of the reverb zone in the scene tab. And this is the scene, yeah. And basically the reverb zone, the way it works, it's the reverb zone targets the camera, the listener, not the source. So the reverb zone doesn't change the source of your sound. It changes the way you hear the sound in the listener, right? Because you have the source and you have the listener. And imagine that the reverb is in a way like a filter for your headphones in a way. So it's like a post-processing thing. It's actually a post-processing, but it targets your camera, and you can make it like infinitely big, right? Like this, if you really want to have it your whole. You add like something like this, and your whole game has reverb, right? Um, let's see. So our camera starts here. Where's the camera? So this is the reverb. This is the camera. Yeah, it starts inside of it. So let's start. So you hear some reverb. If you go closer. So you theoretically should hear it a more intense effect. Not the volume, but the effect of reverb. You see, the more I go outside the reverb zone, the smaller the effect. You see now, like you're like in a completely isolated studio. Yeah, so I mean, you've got the idea, right? And you have lots of effects here. So I don't know, living room, stone room. Yeah. And you see there are lots of effects here. So a sound engineer would basically have these things like physical sliders, and like a sound engineer would really, or sound designer, they would really be at home with this component. Okay, mixer. So Unity Mixer allows us to control all of our sounds at a higher level, just like a digital audio workstation, like a sound engineer would use. But of course, it's a very simplified one. And you don't have to use it when you're just starting out, but it makes a difference. And the easiest but also the most useful example is docking. So when you have some music in the background and you want to, so you have some music in the background and something happens in the foreground, like a shot, like you shoot someone or you hit someone, and the way it works, even if you don't know it, you didn't notice it, the music sound like the music's volume briefly goes down and then up again. So you can hear the sound. It's more in your face, and you don't even notice it. But if you look at the difference, you will definitely see it. Okay. Yeah, let's do that. So we have w2d2 mixers. Mixer. So actually, this thing doesn't need a... Ah, interesting. I think I just forgot to create something here. But it should be easy. So how to create one? Well, this is an asset, not a game. Yeah. So a sound mixer is an asset. So you just do like project view, create audio mixer like this. So right click, create audio mixer, and you get this thing here, and you double click it, and a tab would pop out somewhere, probably here or whatever, but I like it here. And you won't have all of these things here. You'll have it like this, right? You'll have a master, and yeah, I'll have a master, and we create two new groups, background and SFX, and we create them as children of this group, of the master group. And I think you have to select it. If you don't select it, yeah, I mean, I don't know how it works, but I think you can do it like this. Yeah, you can just create them like, but I think you cannot create just outside the master group. Yeah, good. Let's just delete this thing. You create the background and then SFX groups. I mean, let's just try. Let's put the droplets or the highway. Yeah, let's put a highway here. Bam, and let's just play it. So it's a highway sound, and if you go here in the mixer, you should be able to see it here. I don't know why you're not seeing it. Oh, I know why. You have to add, you see, audio source and output. So basically, if there's no output, it will go directly to your speakers. It's in a similar way to how camera works. If the camera doesn't have a target render texture, basically a texture, right? Like this, like a raw image or whatever with the texture, that you also have to create the texture and assign it here, and then you get that texture and drag it here, and it has to be a render texture, like create render texture. Where are you? Somewhere like this. Where are you? Render texture. Render texture, right? And then you assign that render texture to the camera. So this is its target now, and just then you assign it here. So basically, the camera writes to the render texture, and the raw image reads from the render texture, right? And now you will not see anything here. You'd need to create another camera, right? Okay, so back. So that's how I already talked about this, but just it's good to see it because it's a very good analogy to that thing. So in the same way, a sound, if it doesn't have an output target, it goes directly to your speakers in the same way that the camera goes directly to your first display. Like you might have a lot of displays, right? Yeah, but you can now use the audio mixer, this thing here, and you can also like see the layers here. Yeah, you can output this audio source to the mixer group. I don't know why it doesn't work. I think I think I have to do it like this. Oh, okay, yeah, so not the asset itself, right? So the asset is just a file, right? Audio mixer, that mixer, right? And you can look into it like this, and you have lots of things here. Right, it makes sense. So it's everything here, and that's why you can also use Git to, in a limited way, to just see, okay, what was changed? Did you change the name? Okay, you change it from background to background 5 or whatever, and you can easily see changes between like in a team, and that's really cool. Yeah, so now highway outputs to the mixer, to the master channel of this mixer. And you see it here. You can see the sounds here, and you can mute it and whatever. You can do a lot of things here. You can add effects and all of that things, all of those things. Good. Let's go back. Create two groups, background and SFX. We already have them. So like I said, you create it like this. Okay. And make sure they are directly parented to master. Okay. Create an audio source highway, drop highway MP3 on it, assigning it the background mixer group. So our highway is the background group. So it's just a name. Background means background, so music or whatever, right? So we basically double clicked the audio mixer. We see the mixer panel as if we would see the animation panel, right? So we select the background one, or I mean, we again have to select this thing, the audio source, and drag it the background mixer group here. I mean, it's called audio mixer, but it's actually audio mixer group. Good, so we've done that. Then we create an audio source droplets, and we assign it to the SFX group. And I mean, also we have to loop this thing, even though it's long. It's good to loop it. Yeah, let's create another audio source for our droplets, and we don't play it on. I mean, yeah, we play it on awake, and we loop, so it automatically plays, right? Play on awake. We don't have to use code to trigger it or whatever, and we assign it the SFX audio mixer group. Yeah, like this. Now double click again your mixer, select the background group, and add a duck volume effect. So background, and you see I already added it, but background, and you see you can edit it here. And the way you do it, you do like if add effect, duck volume, right? I already have it here because I've already created it, but it's here, this thing here, right? Let's remove it. And for our specific sounds, I've set the threshold to minus 55 decibels. Like it really depends like on the setup, on you basically, it's just trial and error. You have to experiment, yeah. Now double click again your mixer, select the what? I think, yeah, I basically, for some reason, I made this too large. Yeah. So select the background group, then add the DUC volume. Oh, okay. This is just like a duplicate. Okay. Okay, don't worry about it. I think I can just remove this, right? Okay, let's just remove this. Okay. Good. Now select the SFX group and add a send effect. So the way it works, we have the DUC volume, but it doesn't have any input. So DUC volume, what DUC volume is an effect on the background track. So our highway outputs to the background track. And we added an effect that it's not, I mean, a simple effect would just modify your sound. Like you can add like a reverb here as well, I think, or whatever. Yeah, SFX reverb, so you can add a reverb. So it's basically changing the sound, and it goes to master, reverbed. So yeah, this is a way of adding reverb to the source. Remember I said like the reverb zone works on the listener, depending on when the listener is, but if you want to add reverb to the sound itself, to the source, regardless of what the listener, where the listener is and whatever, you add it here. So basically this reverb sound is like a filter. It transforms the sound and it goes to master, right? But the DUC volume is like that, but you can have some inputs like these things here, right? Like the threshold and whatever. But you can have inputs that come from other sounds. I know it sounds a bit more complex, but it's just a step up in functionality. So, for example, you have an SFX. So we've created droplets. So the way it works is pretty simple. So if you have droplets that are sending their sounds to this track, and you have highway sending its sound to this track, they're like combined and go to master, right? But now you have this DUC volume effect, which can receive an input from somewhere. And the way I've set it up, you just go to this SFX, you add a send effect, basically send, right? And here you describe who will receive the information, basically who receives the sound. And here's the only option is this background DUC volume. So what this means is background. So the background group, and DUC volume, the DUC volume effect of the background group, this thing. So this effect, it's not a static effect in the sense that you don't set it here and that's the only thing it does. It's also dynamic in the sense that some of its parameters, internal parameters, will change depending on whoever sends the ducking effect. So again, DUC volume, you see, no send resource connected, right? So it needs a send resource, and the way you send it, again, you go to SFX, and you can like send, and you see again now. I mean, because it has the same name, it doesn't see it, but it doesn't see like two DUC volumes because they have the same name. And that's how it works. So just the first time I saw this, I saw it in Fruity Loops Studio in a tutorial about that software, and it was a bit more complicated there. But here it's a bit simpler because you have less buttons and everything. So just, but I had to watch it like 3 times to understand it. Yeah. So your SFX sounds are sending some the like basically the waveforms information and the volume to this background mixer, but it doesn't send the sound in order to go to the master. It sends it to this effect only, and this effect decides what to do with it later, right? But of course, in parallel, like independently of that, it also the SFX itself sends its sound directly to master. So it just does two things, right? It normally plays the droplets because they are SFX, and it sends them to master. But also this send effect, sends the information about droplets, like the each time a droplet happens, let's say, it sends it to this effect, duck volume. And that this duck volume does this ducking. And what it does, it basically changes this thing like this. It changes small like this, right? Bam, bam. Let's see what else. Yeah. Now play and see how the background group gets cut off whenever a droplet kicks in. Let's see. You see the volume of the background each time the droplet happens. The background volume, drops. You see? And you also see it here. This is basically the signal. So you're in the background layer, but this effect sees the signal that this send effect on this SFX group sends it, right? So it's a behind the scenes thing, right? It doesn't send it in order to play it because it already does it directly to the master, right? It only sends it in silence in a way, right, behind the scenes. And this effect just knows to duck the volume for it. And if you hear it, you can really hear it, right? You can really hear the effects for it. And let's see the difference now. Try increasing the threshold parameter to 0 dB to basically disable the effect. Okay, edit in play mode, which means it will persist the changes. So be careful with this. There's a subtle change. If you are a sound designer, you'd probably get the idea. But if not, or I mean, it depends on your ear. Like, I don't have like a good ear for music, but I get the idea. You see, they overlap. So, but if I undo the change, yeah. So I guess like maybe 80% of you will get the idea, or maybe all of you. I don't know. But it really makes a difference, right? So if you want to make a cinematic scene, or even if you want to, you're creating a shooter game, right? The moment you shoot, you want to hear the fire sound, the firing sound, more prominently than the music on the background, right? So that's how you do it. And it really makes a difference. Like, it's one of those subtle things that you don't notice consciously, but you notice it subconsciously. And you just think the game is better, but you don't know why, right? But this is like one of those 80-20 Pareto principle things that you can do for your game. I mean, actually, let's just keep it like this, right? Let's save it. Sound designers love ducking. Yeah, it turns a 4-star game into a 5-star game. Yeah, you can try some more effects like echo, pitch shifter, you know, depending on your free time. You see, just repeats the sound. Pitch shifter. Yeah, good idea. Congrats, you're now a sound artist. Yeah. Okay, let's do particle systems. And this is the last part of this session, but it's really cool as well. Particle systems, yeah, and you can do stuff like this. And of course, for example, here where you have this shape, of course, you would need like an image that has a similar shape, and you would just deform it and everything. And when you have stars, of course, you would need an image of a star, and you have like puff shape, you need an image of a puff. But the ways in which you can create them in a particle system, like you can have size, color, rotation, speed, transparency, the number of particles, how fast they're generated, how uh, far they travel, uh, a lot of things. Like one particle can also create more particles, and so on and so forth. Let's just take like a 1 minute pause, like just get hydrated and all of that, right? Maybe you want to go to the bathroom or whatever. Hydration is good. All right. Hope you're ready. Um, okay, particle systems. Um, second. Good. Let's do particle systems. So explosions, rain, hits, everyone loves them. You can start with this free asset. So I've already imported it. I won't show you like again, like fifth time how to import an asset. Um, yeah, but let's copy the link and I can give it to you here and on. Oh, we have two concurrent viewers on YouTube. That's perfect. Oh, actually three. No, three. Um, wow, three concurrent viewers. That's a lot. Yeah, that's the asset. So this is the asset, or find it in w2d2 particles plugin in our repo. You don't usually need to create your own, as there are plenty of pre-made on Asset Store. Right. So let's increase the brightness. Um, is here, this thing. So let's create just a simple one. Wait, but oh, I think I just wanted to. Oh, I think I wanted to just show you some of these particle systems, but I didn't like even I didn't create a um a scene for it. Let's go to this legacy because I don't know what that's about. So yeah, it's they have like a demo. So it's a scene where the author of this asset um created some scripts, some whatever things here that just it's just its thing, his thing or her thing where uh yeah, they've created some things here to facilitate exploring the demo. But the particle systems themselves are just prefabs, right? So here electric, and like this is electric, an electric ball. If you put it here, it yeah, you cannot really see it because it's small. No, let's do it like this. I created, I can put it here, and let's say I put it here. Well, anyway, it's just an object. This is it, right? But I mean, I cannot. Anyway, we will see them here easier, but I just wanted to show that it's just an object. It's an object with the component particle system. And you see how big it is, how many in each of these things, see how many parameters they are. So it can stay an entire week inside a single component here. And yeah, you can get really complex. It's like an entire new editor here inside this thing. Um, good. So yeah, you can press this thing here. So, well, I don't know why it doesn't show now. Let's just play it again. Well, it doesn't work for some reason. I'll have to go into this one. Probably this one will work. Yeah. Explosion. There's a lot of things. Oh, okay, it's they are here, and he's only like enabling them when you click them. You see, and now I'm disabling it, like here. enable, disable, right? And that's how it works. Ah, this is an interesting one. This has like more, yeah, there's some more things happening here. Like you have an actual light, of course, a point light, light particle, and you have a firework. I mean, I need like an hour to understand how how this works, right? To create it right from the beginning. But of course, like you can, man, you can color of lifetime, or where is it? You can customize a lot of things from it. Color of a lifetime. Where's the color? Trail. Okay, so you see here the trail, right? You can have it like, I don't know, green. You see the trail is now green, like the trail of all the particles. Yeah, it's pretty cool. I think they do it like with an sub emitter. Anyway, here's the particles, right? So it's very big subject, so we won't go into it. I think like this effect is the most interesting one, because like it has two components, and like it looks complex, but it's not. It's not as complex as it looks. Let's see. Yeah, some like a respawning aura, like bouncing, like some kind of raining puff, smoke. And this is like a more global thing when it happens everywhere at the same time. You have some rain, you can make it bigger, smaller. Oh, and it also interacts with the scene. That's cool. Yeah, you have it like sprinkles and splash, emission, shape, sub emitters. This is like sub emitters and bird. Yeah, sub emitters. That's what it means. Like when the, and you have to, I don't know how you set it up. So you set it up like when the particle hits something, you like have another particle system that starts, right? This one. But you have to, I don't know, somewhere see a effect. Oh, okay, yeah. This is like this his own script, where like you have some camera shake and all of that. That he's using, for example, for explosion, right? So the explosion and everything, it's there's a script that shakes your camera, basically changes the X, Y, and Z position by a fraction, and you see that shake, right? Boing, boom, cursed, poisoned. Yeah. So it starts with the with the explosion. Yeah. Those are also things that you can create in Unity, but of course, infinite possibilities, right? Uh, Particles. Let's go back here on particles and yeah. Let's create just a simple one. Right click on the hierarchy, press effects and particle system. So effects, particle system. That's your particle system, right? And then it already looks decent. Yeah, like you know, something happens, right? Let's see where our camera is. Like I already have the end result here, but I won't show you. I hope I won't show it to you this soon, because I'll just you know, I'll spoil the surprise. So yeah, this is like a particle system. Let's set its emission rate to 100. Emission rate. here in emission rate 100. A lot of them, right? You can also have like 1,000, but they are like you have these max particles, right? And you have to like have it like this, because if you have like maximum particles of 100, they are all like born at once. It's that they are this is their terminology, birth, and they are just saturated, right? Uh yes, 100. There are many thousands of parameters to tweak, so a huge universe. Okay, yeah, and that's why you'll find pre-made particles for anything you want. Uh, so I've created a mission of 100, but I think I didn't actually. I basically have to set this to 1,000, but we'll see. Frequent pattern is to use x over lifetime, which means change x gradually from value A to value B. A being when the particle spawns, and B being when the particle dies. Let's take an example. So let's scroll way up and set the start speed to 1, so we can see more particles in our game screen. Speed to 1, so the speed will be slower. Yeah, okay, start speed to 1. Enable color of a lifetime and set it to go from full orange to full transparent purple. So color over lifetime, somewhere here, color over lifetime, yeah. And let's set it, so start alpha, so to go from full orange to full transparent purple. So starting alpha, okay, and the color to an orange, something like this, to orange. So let's see, I mean orange. Wait, I didn't want to do that. How do I remove this thing with delete? Okay. Uh, Orange. I don't know. Orange? This is orange, right? This is orange? Something like this. Okay. From orange to purple. Something like this. I don't know. Something like this. Is that the way it works here? Yeah, something like that. And here we're like, at the top we select the alpha, so the transparency, and at the bottom we select the color. Yeah. And we go to full transparent. Or full, or just a bit. Yeah, it's full. And it has this effect, so it starts orange, and when it fades, it goes to purple, and then it disappears, right? Yeah. So I basically forgot to add this thing here, max particles. Yeah, now it's better. You see? Better. I don't know, just let me, because this is important, you know. Set rate over time to 100. And okay, back. Well, here I have like a low quality JPEG file image, and that's why it works this way. So let's enable size over lifetime and keep its default. So it means it starts as a small size and it ends as a full size, I think. Yeah, this is the like the curve. Size over lifetime. It looks pretty interesting, at least for me. um, yeah, it's pretty cool. I mean, I really like it. Okay. Yeah, this is the result. Let's bring the purple color closer to the particle's half-life so it kicks sooner. So you see how it starts orange and it linearly goes to purple. And if I move this closer, you see that it starts to be more purple and only orange at the beginning, right? So I think the very middle, there's the like a sweet spot, and I like it to like I'm imagining like it would be maybe when you weld something, right, or when some gas gets inflamed, right, or how it's called, like when a gas leaks from a pipe and it kind of it's a special gas and it's it catch the fire and like from like in the origin where it leaks, it has a color, and then when it goes further away from the leak, it kind of changes its color. Like that's one way, one kind of effect, right? Or a flame, like some kind of a chemical flame. So I don't know, a certain uh, weird gas mm, catches a fire, and at the base it's one color, and you know uh, further from the base has another color, something like that. That's how I've imagined it. So yeah, something like this. Yeah, maybe like even allow it to be more orange. Or actually, yeah, good. Now let's enable trails and go to the renderer section and assign this faded ray material to the trail renderer. Oh, okay, that's why I've imported the asset. Trails, where is it? I haven't used this too much, but I discovered it while creating the course. And we have to assign it a material, but where is it? Go to the renderer section. Oh, okay. Trail material. So we have the trails effect, but of course it doesn't work correctly because we don't have a trail material. And here in the renderer, you have lots of options. And let's see what material. CFX2 faded ray. Trail material. Yeah, okay. Ray. Let's just get it by name. Faded ray. That's, I think, what it's called. And it's this material, and it's a legacy shader, particles, additive. Oh, okay, this is a very standard particle material from Unity, like since 10 years ago or something. So it's a standard one. Yeah, and so it's a material that they've created using this shader. Additive means that when a particle goes on top of another and another, they are adding up their colors. So it's as if you are seeing two transparent pieces of glass, and one is blue and one is yellow, and their combination is green, right? It's something like that. So they are like for transparent things because particles most of the time are transparent. And they've added this texture, which is their texture. It's an image from their package, right? From this free asset, which is in PNG, which has this thing here, has this shape. And I think, yeah, there's like no alpha source. There's no transparency because they didn't need it. Because the particles shader automatically treats the black parts as transparent and white parts as, of course, opaque. Okay, let's Control Z. And yeah, they like put some tint, so it's like a grayish color and also some transparency by default. So it's not completely opaque and in no point at no point. Good. That's the material. Um, good. So we've added a trail renderer. So again, we went here, trails, enabled it, and by default we just use the default ones. And then we need to assign the trail material. I mean, they should have put this material here, but I don't know. Maybe for legacy reasons, it's like that. Yeah, this is it. Enable the noise and set the strength to 0.2. And the noise usually means some disturbances, some randomness that we can add. Noise. Where's noise? You see, you can create lots of things, and we haven't even started. I mean, we won't go into a lot of details. Like we might even experiment like 1 millionth part of the whole universe of possibilities. Um, yeah, 0.2, and this is like strength, 0.2. Strength, like if we created, the smaller we go. Two. See, it's kind of interesting now. More interesting. Yeah. Final touch. Scroll up to the speed property and set it as random between two constants. So starting speed, let's go starting speed. Starting speed, we have it as 1. But we can, for each particle, we can set a random speed when it starts. So it can be between 5 and 1, or I mean, it should have been like from between 1 and 5. And let's set it from 0.8 to 1.2. And now you see like some particles are faster than others. And you see there's even more randomness now, right? Nice. Um, I just want to try this thing. Like when there are lots of, even in nature, like lots of like plants, when they start small, they are more, they are whiter, right? And then when they grow in their like natural color. And that's another thing here that you can just experiment with it. Experiment with. Uh, you can have them like this. It's kind of like a fire now. Oh man, I like this more. This is better. Yeah, and this is it. Like this is like the final one, and this is this thing here. Let's change this thing. Like let's disable it, and let's. Yeah, this thing looks even better. I think. I mean, even better than the one before with orange and uh, uh, pink, purple. Yeah, I like it. This is particles, and we only used a an outside texture for the trail, but the particle itself is a just the default particle material, which is this default material from Unity, like that you can't select an asset here because it's built inside Unity's installed folder, and you have it here by default, right? And it's this thing, right? I mean, we can, I don't know, maybe select another material. Just trying out, right? But I want this to play. Why don't you play? Oh, okay, play, please. Uh, can I select now? Yeah, I can select now. Um, yeah, I don't know. Maybe this thing. No, it doesn't work. No, it doesn't work. Oh, it has to be like a particle system material. Yeah, it has to be a particle. But we can use these ones. I don't know. You see? Whoa, this is so interesting. Okay. Yeah, and you can like rotate them and all of these things, right? Yeah, you know, like lots of things that you can experiment with, right? You got the idea, right? I just it's interesting for me. Yeah. Okay. Last one. Last one. uh Good. So that's your particle systems, and congratulations, you're a VFX expert now. Yeah, and here's the meme for you. The client wanted a more realistic fire. I gave him some. Okay, that's funny for me at least. And see you later. That's today's session. So we're I don't know how many minutes in, but yeah, thanks for joining. And as I said, uh, tomorrow we will do coding. So we will enter the C sharp realm and programming, and most of the time we'll actually spend talking about um, best practices, code architecture, and a lot of other things, cool things, at least for me. Um, yeah, and it won't be as long as I previously stated. Just I said like it would be probably 4 hours or 5 hours, but just maybe maximum 3 hours. So you're already used to that. We already had the 3 hours session and even 4 hours. Yeah, 4 hours. Yesterday actually. Um, yeah, we'll do mostly C sharp. So it probably has like maybe 5% gaming stuff. So even like if you have any programmer coder friend or wannabe coder programmer friend, just you can show him this stream. He can see the recorded one or join live if they want to ask questions. It's just free question asking. But I mean, you can you or your friends can also join. Sorry, can join the Discord server, and since there's not too many of them there, of you there, I can just answer questions from time to time there as well, like any kind of questions. So that's your free source of information. Um, yeah, and the day after we will do coding but applied to Unity, and the day after we'll do, I think, yeah, microservices, like how you can show, how can you store your data on a remote server or like Firebase, which is free for if your game is not too big, it's free, and you can like create a chat. You can do some other things like yeah, like that, and I think that's our uh week. I don't know. I just missed something, but yeah, we have like uh coding tomorrow, C# coding, and anybody can see it, whether you're a game developer or not. And the day after, we will do coding applied to Unity. And if you don't have any questions, I guess I'll see you tomorrow. See you. Have a nice evening. Bye.